What if I told you that over a century ago, two scientists uncovered a secret hidden in light and magnetism, one so powerful it still shapes our world today? From unlocking the mysteries of the universe to powering life-saving technology, their discovery changed everything. This is the story of Hendrik, Lorentz, and Pieter Zeeman, the breakthrough that won them a Nobel Prize, and how it continues to impact your life in ways you never imagined. Stick around, you don't want to miss this. The mind-blowing discovery, the Zeeman effect. Imagine you're at a concert, and each instrument plays a distinct note. But suddenly, a force field appears, and each note splits into a chorus of harmonies. That's what happened when Pieter Zeeman placed a light source in a magnetic field. In 1896, Zeeman observed something astonishing when a magnetic field was applied to a flame, specifically one containing sodium. The flame's light, usually showing a single note or spectral line, suddenly split into several notes. This phenomenon was later called the Zeeman effect. This wasn't just a light show, it was a clue that magnetic fields could influence light at the atomic level. It was like finding a hidden control panel for the universe's glow. But how did Zeeman stumble upon this discovery? The story goes that as a young scientist, he was fascinated by how magnetism could influence light, a curiosity sparked when he witnessed an aurora borealis. He set up experiments using primitive equipment. Think of it as trying to decode the cosmos with a magnifying glass and a candle. But it worked, and his observations shocked the scientific community. The science behind the magic, Lorentz's genius. But a good magic trick needs a magician who can explain it. Enter Hendrik Lorentz, the theoretical wizard who put the pieces together. Lorentz had this wild idea. What if atoms were tiny orchestras of charged particles, like electrons, playing light as their music? When a magnetic field swept through, it changed the way these electrons played, causing the light to split into different frequencies, just like Zeeman saw. He even developed precise mathematical formulas to predict how the light would split, and bam, they matched Zeeman's experiments perfectly. It was a moment of harmony between theory and reality that most scientists only dream of. What Lorentz did was more than just explain Zeeman's findings. He laid down the theoretical framework that bridged classical physics and what would eventually become quantum mechanics. His equations were like blueprints for the mysterious inner workings of atoms, helping scientists understand how light interacts with matter. Why they won the Nobel Prize. The Nobel Prize Committee couldn't ignore this dude of discovery. Lorentz and Zeeman didn't just find a new effect, they had uncovered a universal rule. Their work proved electrons exist way before they could even see them. Showed how light and magnetism are linked, helping to bridge classical and quantum physics. It was like they'd found a hidden lever in the laws of nature, showing scientists how to turn light on its head using magnetism. But here's the kicker. Their work also demonstrated that light wasn't just a wave, but had particle-like properties, a hint at the wave-particle duality that would later become a cornerstone of quantum physics. They essentially handed future scientists a master key to unlock the mysteries of the quantum world. How their work changed the world. 1. Shaping quantum mechanics. This discovery became a cornerstone of quantum mechanics. The Zeeman effect helped scientists develop the Bohr model of the atom, which included the idea of electron spin and quantum numbers, concepts that would eventually help us build everything from lasers to microchips. It was as if Zeeman and Lorentz had drawn the first sketch of a blueprint, and future scientists like Niels Bohr and Werner Heisenberg turned it into a high-tech architectural marvel. Their work showed that atoms had a hidden structure, a secret code of behavior, when cracked, allowed us to harness the power of the atom itself. 2. Unlocking the secrets of the universe. Have you ever wondered how scientists know what distant stars are made of or the strength of magnetic fields on the surface of the sun? The Zeeman effect is like a cosmic fingerprint scanner. By analyzing how light from stars splits in a magnetic field, astrophysicists can decode the magnetic mysteries of our universe, whether it's studying sunspots or understanding the violent storms of magnetars, the magnetic monsters of space. This technique allows astronomers to peek behind the cosmic curtain, revealing secrets of galaxies, black holes, and even the birth of stars. It's like being able to listen to the universe's heartbeat through the magnetic rhythms of light. 3. Supercharging spectroscopy. The Zeeman effect didn't just stay in a lab. It became a powerful tool in spectroscopy, a technique that helps scientists identify elements by their light emissions. In chemistry, it's used to uncover the secrets of molecules. In material science, it helps create new materials by showing how atoms behave. In environmental science, it even helps track pollutants and understand our atmosphere. It's like having X-ray vision for the tiniest building blocks of our world. Spectroscopy based on the Zeeman effect helps everything from identifying elements on distant planets to developing safer pharmaceuticals right here on Earth. Saving lives with MRI technology. But wait, there's more. The science behind the Zeeman effect indirectly helped give rise to magnetic resonance imaging, (MRI) technology. An MRI is basically a superpowered camera that uses magnetic fields to look inside your body. It's a game changer in medical diagnostics, giving doctors the ability to spot diseases early without invasive procedures. Imagine if Zeeman and Lorentz could see this. They'd probably think it was straight out of a sci-fi novel. The legacy, from Nobel glory to everyday life. Lorentz and Zeeman's story is a reminder that sometimes the tiniest particles and the strangest experiments can change the course of history. From helping us understand the quantum world to enabling life-saving technologies, their work shows how curiosity-driven science can transform our everyday lives. If you love this dive into the history of science, smash that like button, share with a fellow science enthusiast, and don't forget to subscribe for more mind-bending stories from the world of physics, tech, and beyond. Who knows? Maybe the next big discovery we talk about will be yours.